We want to find the distance from a point to a line in 3 space by using a projection. So we have this point, 1, 2, negative 3. Let's go ahead and draw a graphic so we can visualize it. We have a line like this. And the distance from the point to the line will be this perpendicular thing. Now, how do we find that? What's our strategy going to be? We want to use a projection to get there. Well, we need to pick a point on the line. Well, looking at our line here, a point on the line, if t is 0, is negative 4, 5, 1. And the direction vector of the line is what? If we look at the multiples of t, 2, negative 1, 6. So what are we going to project? How are we going to use it? We picked a point Q on the line. Here's our point Q. And that point is negative 4, 5, 1. And from Q, we're going to construct the vector Q to P. So what is that vector from Q to P? So we have the vector Q, excuse me, the point Q is negative 4, 5, 1. You have the point P, which is 1, 2, negative 3. What is the vector from Q to P? From negative 4 to 1 is up 5. From 5 to 2 goes down 3. From 1 to negative 3 goes down 4. So we have QP, we have the direction vector. So let's go ahead and give us a version of the direction vector. And I like to assume it's bigger than it actually is. So let's say this blue thing is the direction vector. If I project QP onto the direction vector, I get an important piece, but not the distance. This thing right here is the projection of the vector QP, which is here, onto the direction vector. So that distance is represented by the projection of QP onto dV. But I need you to recognize that is not the distance. We will use that to get the distance. Where is the distance? The distance is here. The distance from the point to the plane is there. But I have QP, I have the direction vector. QP is here. Direction vector is there. Let's go ahead and find the projection of QP onto dV. So here's our vectors. Let's remind ourselves of the rule. The rule is the projection of U onto V is U dot V over V dot V times V. So in my case here, I want the projection of QP onto dV. It's going to be QP dot dV over dV dot dV times dV. So will that give us what is QP dot dV? Let's see. 5 times 2 is 10. Plus negative 3 times negative 1 is 3. Plus negative 4 times 6 is negative 24. Over dV dot dV, 2 times 2 is 4. Negative 1 times negative 1 is 1. Plus 6 times 6 is 36 times the direction vector, which of course is 2, negative 1, 6. So our projection of QP onto dV is 13 minus 24, so negative 11 over 41. Is that right? Times the direction vector, 2, negative 1, 6. So I want the magnitude of the projection of QP onto DV. Let's take a look at our picture again. This is what we're working with. Can I get the length of that vector together with the length of that vector will enable me to get the distance? Do you see how that's going to work? What's our strategy going to be? So the magnitude of the projection of QP onto DV is going to be the absolute value of negative 11 over 41 times the magnitude of 2 negative 1/6, which of course is 11 over 41 times the square root of 4 plus 1 plus 36, root 41. So we get 11 over the square root of 41. So we have that length. We also can figure out the magnitude of QP. So up earlier, we have QP is 5, negative 3, negative 4. So what's the magnitude of QP? Square root 25 plus 9 plus 16, which is root 50, or 5 root 2 if you prefer. So that gives us the magnitude of QP, but again, we have to look at our picture. We know the magnitude of QP, we know the magnitude of the projection of QP onto the direction vector. Do you see how this is going to have to work? We know this magnitude, we know this magnitude, we want to get the third side of the triangle. And the tool we need to use, of course, is the Pythagorean theorem. So looking at those three sides of the triangle, I need the magnitude of the projection of QP onto DV squared plus the distance squared equals the magnitude of QP squared. A squared plus B squared equals C squared. And what did we say the magnitude of the projection was? We had said the magnitude of the projection of QP onto DV was 11 over root 41. I need the magnitude of that projection squared. 11 squared is 121. Root 41 squared is 41. And how about the magnitude of QP squared? Magnitude of QP was root 50. So root 50 squared is 50. So now let's go ahead and plug these in and see what we get. The magnitude of the projection squared, so 121 over 41, plus the distance squared equals the magnitude of QP squared equals 50. So the distance squared is 50 minus 121 over 41, which is 1929 over 41. So the distance is the square root of 1929 over 41, which is approximately 6.859 units.